Saxon's Calculus Lesson 32 is about roots of complex numbers and trigonometric functions of n theta. And that's basically meaning there's a number in front of the theta. And we'll get to that, obviously. Part A then is roots, answers of a complex number. Complex meaning it's got the imaginary or the I stuff in it. So if we jump over to example 1, you should recognize this from trig. It asked for 4 fourth roots, so it's basically looking for 4, so you'll have 4 answers in a fourth root of, and then it gives me I. Now, I need to remember before I can do anything else that i's appear at the end of these, so there should be 2 parts, an x part and a y part. And this one gives me the I piece, so I know it's implying a 1, but I was not given an x term, so it should imply a 0 there plus 1i, and then however many the roots are, that's how many answers you will have. So that's why it said find 4 fourth roots of this. Now, I can't do it unless I'm in the cis format, and this is in the rectangular, so we need it in its polar cis. So we need to graph it. I did not move over on the x line, but I did move up on the y line to a 1. And then that would imply a triangle going up to that point and down. So technically I'm not going over any, I can label that, and this one would be labeled a 1. And if the side is 0, then I know the hypotenuse has to match. Okay, so in cis format, remember that that stands for cosine plus I sine, but it means hypotenuse is here and degree is here. So the hypotenuse we just found to be 1. And then what is the degree here? If I am going over but not up, that's this line. So that's 90 degrees. Now it's in cis form. Now I can do the 4 fourth roots of this. And the way we do that is we do the fourth root of 1, which is going to be 1. And because it told me I will have 4 answers, I can go ahead and write that answer for each of them. And then to get the degree, I do 90 divided by whatever the exponent was. So I don't try to do like the fourth root of 90, it's a division. So 90 divided by 4 gives me 22.5 degrees for the first answer. Now to establish a pattern for how I get the other degrees, what is a basic circle? 360, and so to establish the pattern, I do 360 divided by whatever the root number is. 4, in this case, then I'm adding 90 degrees each time. So 22.5 plus 90 should be 112.5 degrees. Add 90 again, 202.5 degrees, and add 90 again, 292.5 degrees. And there are the 4 fourth roots of. Example 2, use a calculator and decimal numbers to estimate, and it gives us a 5th root symbol of negative 17 plus 4, oh, that's not 14 squared, I knew that didn't seem right, 14i. Make sure I wrote that right since I was having trouble. Yes, okay. Again, not in the correct cis format to do it. So we're going to graph negative 17 and 14 up would graph us here in the second quadrant. So negative 17, 14 up. Pythagorean theorem of that will give me the hypotenuse that I need to be in front of the cis. And that's why it says use a calculator. So 17 squared plus 14 squared and then square rooting that answer is going to give us 22.02. So my hypotenuse is 22.02 written here in front of my cis. Now I need the degree. So since I found this one and I might have rounded this decimal off, I'm going to stick to using the 14 and the 17. So the 14 is opposite the theta, the 17 is adjacent. So which word uses opposite and adjacent? Tangent. So we're going to do tangent of theta equals TOA, so 14 over the 17. And again, remember, we don't use the signs with this because we're going to do this adjustment to the quadrant that it lands in on our own. So just do 14 divided by 17. Because you want the degree, you're going to hit second, shift, inverse, whatever your calculator uses, tangent, and it should be giving you a theta that is 39.47. Now, before we write it here, we need to adjust it because it's in the second quadrant, so it didn't quite reach 180. So 180 minus 39.47. Sorry, I was like, why are they in the third quadrant? Oh dear, I did have a problem when I wrote this. It was minus. It should be in the third quadrant. Everything else is the same. My hypotenuse isn't going to change because the Pythagorean theorem works the same. But it's 180 plus the 39.47. Good thing I caught it when I did. So that's 219.47 degrees. Yeah, because that would be negative 14 and that was the negative 17. So let's get rid of all that. Okay, now we should be back on track. Fifth roots of. So we're going to do 22.02 fifth root on the calculator, and that should give us 1.86 cis. And then I know I should have 5 answers because it was fifth root. 1, 2, 3, 4, 5. Yep. Okay. All right, now we're set up. So 219.47 is going to divide by 5 to get the starting degree, which will be 43.89. And then again, how do I get the pattern? I take 360 and divide it by whatever my root number was, and that now tells me that I'm adding each time. Oh, I was looking for them to tell me what 360, oh, there it is, 43.89. So we're adding 43.89. No, that's that first one. Hang on. Oh, does it happen to be the same number? Hang on. I don't think so. Oh, it's not 43.89. It can't be. I'm misreading it in my quickly. Did they not tell me the number? Oh, phooey, they didn't. Okay, hang on. 70, I'm adding 72 each time. So now 0.89, add the 2, 7, 8, 9, 10. So 115, I want to make sure we're on the right track. Yes, 115.89. Then continue to add 72 degrees. So that's going to give you 187.89 degrees. Add another 72, and we get 259.89 degrees, and one more 72. 331.89 degrees are 5 answers for the fifth root then. Oh, okay. Part B is the trigonometric functions when I'm wrapping not a full time, either a part of a time or I'm continuing to wrap more than once. So for example, example 3 says solve the sine of 3 theta. So that tells me that I'm wrapping 3 times around to get the sets of answers. And I am provided that I'm bounded between the 0 and the 360, which is how I know I'm only supposed to go. All of my answers will fall between here, but to do that, I will wrap 3 times, and you'll see how that just automatically works. So we're going to graph. Which quadrant do we graph for sine? Well, it's all or students, but we're going to stick with the first one. No, I'm going to put it in both, all and students. So then my sine is opposite over hypotenuse. The opposite is 1. The hypotenuse is 2. Memorized, then that's root 3, negative root 3. And then opposite the 1 is 30 degrees in both of these places. So my 3 theta equals 30 degrees, and my 3 theta equals 180 shy by 30 is 150 degrees. So my actual thetas, when I work that out, is 10 and 50. So those are very small. So then this tells me continue to wrap again and 1 more time. So 3 total. These 2 give me the first wrapping around. So then do 360 plus the original 30, and you get 390. And do the 360 plus 150, 64, 360, what is that, 510? Why am I having trouble doing that in my head? So that's 7, hang on, I have to write it. 360 and the 150, 510, okay, that sounds better. And then my final wrap, and I'll go back and do this division here in a second. I want to go ahead and finish these. So wrapping twice makes it 720 degrees plus the original 30, that's 750, and then the 150 for this one, 5, 7, so 870. Okay, now we're finished. Then we do the divides by threes, and you'll see that we end up with answers that are less than 360. So 390 divided by 3 is 130 degrees. 510 is 170. 750 would be 250. I'll check these in a second. And then 2... what is that? I want to say 290. Okay, now let me check those. 10, 50, 130, 170, 250, 290. Yes, there we go. Okay, and that is below the 360. So that's how this number in front tells me how many times to wrap. Okay. The example that, or the one that they gave before they did that example was actually sine of theta equals 1/2. Oh, no. That's fine. I'm going to leave the example there, but I'm going to put this half here. If I have a half in front of the theta, then when I go to graph that, I'm only going to end up in this first quadrant because it's only half of my wrapping that will work to stay bounded. Whatever my numbers worked out to be would end up being over 360 if I tried to use that quadrant, because it says I'm only going to be able to do half of what I needed to do. But your numbers will tell you these things without you needing to worry about it. And the reason I wanted to go back to that was because example 4 says tangent of 4 theta, so it's wrapping 4 times, and I wanted to talk about a half wrap. In theirs, they have it as minus √3/3 equals 0. I'm going to go ahead and fix it because I wrote the equal and move the √3/3 to the side. So where it was minusing on this side as it was given, it's positive over here, of course. Bounded between 0 and 360, so I know my answers are all going to be in degrees, thankfully not in radians. And then this I recognize as having been fixed by multiplying by √3/3. So what it really originated as was 1/√3, which is important for graphing because tangent is opposite over adjacent. So now in which quadrants is tangent positive? In all, not students, yes, take, and then not in calculus. So my opposites are 1s, or in this case, -1. And don't panic because I'll fill in the other number. Adjacent is √3, and here the adjacent is -√3. And negative divided by negative is positive, so that is acceptable. Then the hypotenuses are 2, so memorized again, that comes out 30 degrees. So we have 4 theta equals, in this original one then, 30 degrees. 4 theta equals 180 plus 30 more is 210. And then theta will equal 30 divided by 4, it's going to be a decimal, 7.5, really tiny. And then 210 divided by 4 is 52.5. And now we continue with our wrapping 4 times. So 1 time, 2 times, 3 times, 4 times. Okay. All right, so the first time we're doing 360 plus our 30, 390, 360 plus our 210, 570, And again, I'll go back and do the divisions. Then wrapping twice is 720 plus the original 30, 750. And then 720 plus the 210, 930. And then wrapping another time, I don't have this one memorized, but it's basically 360 times 3. So 0, 18, so 1,080 plus the original 30, 2010. Is that possibly right? Oh, I don't even think they told me that number. And then I can do it, 8, 9, 10, 11. Oh no, 1, 1, 1, okay. All right, so we check our numbers. And then our 1,080 plus our 210, 9, 2, so 1,290. Okay, now, divide by 4. 390 divided by 4. Oh, there is their numbers. Yes, I finally found them. Okay, so that's 97.5 degrees. The 570 divided by 4 is 142.5. 750 divided is 187.5. The next one of 930 divided is 232.5. And then 1,110 divided, 277.5. And finally, 322.5 degrees. There's our series of answers, but it's just shy of the 368 as we would expect it to be.